Welcome to our last video for Unit 5. Our goal for today is to convert between systems of measurement. So we're going to switch between customary and metric as we so choose. Evidence-wise, we're going to use the conversion rates. They're the same ones that we learned in the last video. If you haven't watched that, make sure you go watch it. There's a card up in the top right corner there for you to click on if you need. And then we're also going to understand the connection between metric and customary units. It's not too bad. It's basically the same thing that we did in the last video, just relating two different types of units instead of two different units. Learning experience, we're going to look at some more tables. You're going to copy them down. Then we'll do an example. We'll have a you do, things to remember, and then suggested practice problems at the end. So let's move right into it. So the first thing that we're going to do here is look at some new tables. Pause the video. Make sure you write these down, just like we did in the previous one. Essentially what we're doing here is we're taking some of the common units and comparing them and seeing how they're equal. So you see that 1 meter is about equal to 3.28 feet. 1 meter is equal to 39.37 inches. 1 inch is equal to 2.54 centimeters. And of course 1 mile is equal to 1.61 kilometers. You have the same ideas with capacity. You have the same ideas with weight. You're just taking some of the measurements that you would use in either metric or customary, and adjusting them as you need. Now, one thing that you might not be aware of as we're looking at this is what this symbol means. It's like a little equal sign, but it's kind of wiggly. It kind of looks like a piece of bacon.
Bacon.
What this squiggly, bacony equal sign actually means, it means almost equal to. It's not exactly that thing, but it's pretty close, and it's close enough that it's good enough for what we're going to do. That's what that means. Write that down as well if you need to. It's not necessary, but just so you know what it means, it might not be a bad thing. So again, pause the video if you didn't previously. Make sure you write all of this down. So let's use this in a real scenario. Mr. H, that's me. I went to IKEA to buy a new bookshelf for all of my math books. However, I can't buy anything longer than 30 inches as it's not going to fit into my house. Mr. H finds Billy the bookcase, which looks nice, you can see it there, but it's measured as 80 centimeters. If you didn't know, IKEA is a Swedish company. Because they're European, they're going to measure things in metric. Would this bookshelf fit in Mr. H's house? That's what we're going to figure out. So the first thing that we're going to do is we are going to find our pen. There we go. The first thing that we're going to do is we're just going to write down this 80 centimeters. Since we don't know what that is, but we want to compare it to 30 inches, at the end of our problem, we're going to want to make sure that our answer is going to be in inches. So, if we look at the tables that you guys wrote down from the previous one, you'll see that 1 inch is equal to 2.54 centimeters. This means that we can make a rate. We can either have 1 inch over 2.54 centimeters, or we could have 2.54 centimeters over 1 inch, depending on what we need. If we think back to our last video, we'll remember that whatever we want to find needs to go on top. So that means that we're going to use this ratio because it has inches on top. The centimeters are going to go on the bottom. That means that when we multiply these together, we're going to be able to cross off the centimeters because there's centimeters on top as well as on bottom. That will just leave us with inches. So now that we've set up our problem, we have to actually go through and do this. Technically, we're going to do 80 times 1, which would just be 80. We'll squeeze this in here. It should just be 80. And then we just have our 2.54 on the bottom. But that means that we're going to divide. We want to make this into a single number instead of a fraction. So what we could do is we could set something up that would be 80 divided by 2.54. But since we don't have a whole number as our divisor, we're going to need to move our decimal point over. To make it a whole number, we're going to need to move it over twice. So that means our new long division problem is going to be 254 on our outside and 8,000 on the inside. Past this is just normal long division. Does 254 go into 8? Absolutely not. Does it go into 80? Still no. Does it go into 800? Yes. And I actually know that it's going to go in 3 times, because 4 times just 200 would already be 800. If we have this extra 54, it can't be more than 3 times. Let's figure out what 3 times 254 is. We'll draw this over here on the billy. So 3 times 4 is 12, carry the 1, 15, 16, carry the 1, 6, 7. So we have 762 subtracted from 800. We have to borrow a 7, which means we're going to borrow 1 from here and here. We get 8, 3, and 0. We have to take our next 0, drop it down. How many times does 254 go into 380? Just once. We know that's just going to be 254. We subtract. We have to borrow 1 from the 8. So this will be a 6. 7 minus 5 is 2. 3 minus 2 is 1. And technically we should keep going. But let's consider what the question was. Our original question was, would this bookshelf fit into Mr. H's house? So far, we know that the bookshelf is 31 point something inches. We haven't done the something. But we know that we also can't buy anything that's longer than 30 inches. So already, we can just stop there and say that we can even use our about equal sign. We can say that's about equal to 31 inches. So, would this bookshelf fit into Mr. H's house? No. We cannot buy Billy the bookshelf because he's too big, he's too wide. And that's it. This looks like a lot of work, but that's really down to the long division. Past that, it's just setting up your equation, finding your rate to convert units, and that's it. That's all you gotta do. Pause the video in case you need to write any of this down before we look at our you-do for today. In our you-do problem for today, we have this scenario. Shopping for a new bookshelf has made Mr. H thirsty. He goes by the food section in IKEA and buys some dricklingon. I have no idea if that's how it's pronounced. Anyway, it comes in a 1.25 quart container. What I'd like you to do is figure out how many liters of the stuff I actually bought. So again, look at that table from earlier in the video. You should have copied it down. And use that to help you solve this problem. Pause the video. Ready, go. So things to remember from this video. They're actually exactly the same as in the 5.8 video because it's the same ideas, really. The unit conversions are going to be different depending on which system you use. If you use metric, it's going to look one way. If you use imperial, it's going to look different. In this video, though, remember that we learned what conversions we can use to change between the two systems, which is kind of nice, especially if you're an American going to anywhere else basically in the world, unless it's Myanmar or Liberia. They still use the imperial system, but pretty much everything else uses metric. Then, when using a conversion ratio, always put the value you want on top of your fraction and the value that you already have on the bottom. In the example, we had centimeters, so we put centimeters on bottom. We wanted inches, so we put inches on top. Finally, you either multiply or divide, or both, depending on the problem. Though I don't think you're going to see many problems this year, at least, where you're going to have to do both. So our suggested practice problems for today come from Savas again. There's 4 of them here for you. In each of these, you are converting from either customary imperial units to metric or vice versa. Pause the video, write them down, and of course, good luck.